Alright guys, so lastly, we're going to combine what we've done over the previous days on the unit, and now we're going to take word problems and we're going to write equations. So, we're going to take those two scales and mash them together. Just to kind of help you with that, you may be given a graph or you may be given words, so just to refresh you and help you out on this, if you have a graph, like for our y-intercept, so you're going to have, come on, nope, I don't want this one, there we go. So you're going to have like your graph going on. I'm just going to go ahead real quick. We can use this. I'm going to use the same picture in all of these, that way we have it all nice and uniform across the board, though my picture is not that lovely. So our y-intercept, again, is just whatever point where it crosses the y-axis. So that's going to be denoted by 0 and then some number. Okay. Keywords you're going to look at are in word problems are where you see like starts, begins, initial, anything like that. So if you see anything starting like it starts at this point or it begins here, that's going to be a good indication about that's your x-intercept. Or y-intercept, sorry. Your x-intercept is going to be right here. Then that'll be denoted by where you have a number and then 0. And here you're going to be looking for keywords like lands, maybe crashes, hits, or anything to do with like the ground. Those are going to be some big keywords. With both of these, our vertex, we're going to be looking at different things. So the y part of our vertex, basically, we could think of it as that line right here. So your vertex is going to be at h and then k, just using our vertex form notation. So your k is going to be the y part of your vertex, and that's going to be like, look for like the max height, or highest. You could also have it where maybe your parabola is concave down, so that would be your min height or lowest. And then the x part of your vertex is going to be the vertical line that goes through that, or you can think of this as your axis of symmetry. Thinking back to our previous unit, and that's going to be the time. Look for things that talk about the time to the max or the min, or like how long, things like that. So looking at some general steps on how to do this. One thing that I find really helpful is first it's to just draw a picture. And then along with that, label your points. Points or key info. It helps you to see what you're going to be using. And then we got to decide what form to use. And that's based on the key features. And then 3, we got to plug in our key features. And then lastly, we got to solve for our A value or our rate of change. And that's how we do it. So draw a picture, label what you got, decide what form you're going to use, and then plug all those things in and solve for your A. So looking at our equations, let's go on to the next one and see, or our next page, sorry, and see what's going on here. We'll probably do these first 2, and then I will leave you guys on your own to find the last one. So here we have that Sean is kicking a soccer ball to his dad, who is 10 meters away. If after 2 meters the ball is 1 meter in the air, write the equation that represents the path of the ball. So he's kicking a soccer ball, so I don't know. That's sure. Sean is kicking the soccer ball to his dad. Dad's over here. We know Dad is 10 meters away. Maybe they're in England. Well, they are playing soccer, but they're calling it soccer, so I don't know. So he kicks the ball. We're just going to assume the ball takes a parabolic course. And so then the ball's like right here. So if when it's 2 meters away, so we got 2 meters there, the ball's 1 meter in the air. Okay, so let's make this maybe a little bit more scientific, or not scientific, mathematical. So we kick it like that. So we're going to have points here and here. Points are going to be 0, 0, because we got to make a starting point. And then Dad is 10 meters away, so Dad's going to be at 10, 0. Then we're going to have a point on the graph. Excuse me, sorry. So then we're going to have a point on the graph where it's our x is 2 and our y is 1. So now we can kind of see what's going on here. Now we want to go and try to make our equations. So we're given our x-intercepts because the ball starts on the ground and then gets to his dad on the ground. So we have our x-intercepts. Those are 0, 0 and 10, 0. Or if we want to label these even more, we could say, hey, that's our P, that's our Q. Then we have a point of 2 and then 1. And so with that, guys, we can go ahead and use our intercept form to be able to create an equation. So we would have y is equal to a times x minus p times x minus q, because we're given our x-intercepts. So we plug in p, so we'd have y is equal to a times x minus 0 times x, and then we got to do minus 10 because it's a positive 10. And now 2's our x, 1's our y, so we plug that in. We'd have 1 is equal to a times 2 minus 0 times 2 minus 10. So we have 1 is equal to a times 2 times negative 8. 2 times negative 8 is negative 16, so we'd have 1 is equal to negative 16a. Get a by itself, divide by negative 16. And so So then a is equal to negative 1/16. Okay, we don't really like having the negative on the bottom, so that's why I put it out front there. And so then we have our a. So let's plug that into our first equation. Oh, not that one. That one right there. So then our equation would be y is equal to negative 1/16 times x minus 0 times x minus 10. Okay, so that's one of them. Let's do another example to help you. So May hit his softball so that its maximum height was 60 feet at 3 seconds after she hit it. If the ball, I'm going to assume that said starts, 3.5 feet above the ground, what is the path of the ball in terms of seconds?
Mr. Dabrowski, if you're available, please come to the main office. Mr. Dabrowski, if you're available, please come to the main office.
Okay, so let's sketch this graph. So it starts at 3.5 feet above the ground. So it's going to be our y-intercept. So our y-intercept is going to be 0 and then 3.5. She hits the softball to its maximum height. That's going to be our vertex, and that's going to be at 60 feet at 3 seconds. So we're going to do 3 and then 60 for our point. Let me just move that closer over here. And then this path is going to follow a parabola. Okay. So you can think about this. They're hitting, she's either hitting from a tee, I don't know, batting practice, or in a game, hits it so it's 60 feet above the air, above the ground, and then comes back down. So since we're using a maximum, like we said here, max normally refers to the vertex. So our vertex is going to be at 3 and then 60. And then we have another point, or our point is technically our y-intercept, is at 0 and then 3.5. So now we're going to just use our vertex form where we have y is equal to a times x minus h squared plus k. Plug in our vertex, so we get y is equal to a times x minus 3 squared plus 60. Plug in our point, so we get 3.5 equals a times, oops, that's not going to be x, that's going to be a 0 minus 3 squared plus 60. And so then we get 3.5 is equal to a times negative 3 squared plus 60. Negative 3 squared is 9, so we get 3.5 is equal to 9a plus 60. Now we gotta subtract 60 to move it over. So then we get negative 56.5 is equal to 9a. Now we divide by 9. This one's not going to be pretty, so you got to put it into your calculator, and we would get a is equal to negative 6.28. So that's our a. Plug that back in, so we'd get y is equal to negative 6.28 times x minus 3 squared plus 60. That's how we'd get that one. Okay, for this, I'll leave this last one for you guys to do. I will give you the answer. So at the end, you should get y is equal to a, or not a, sorry, negative 15 over 121 times x minus 0 times x minus 22. So you're going to be using intercept form there. If you're having problems, please reach out and let me know.